Now in this video we're going to talk about bonding. In fact, we're going to start the discussion about the shapes of the orbitals in terms of what we predict from Lewis theory. Now this is also going to build into what's called hybridization, which will be in a later video. But the two topics we're going to talk about here are sigma versus pi bond. So what's the difference between a sigma bond, a pi bond, and a delta bond? Let's say we have two carbon atoms sitting in space. Carbon 1 starting out with 4 electrons. And carbon 2 starting out with 4 electrons. Now, in all our previous videos, we talked about when we do bonding, we always form one initial bond between the two atoms. In this case, we're going to have, that's our first single bond. Now, if we were to draw what this looked like in space, what we see is that the two carbon atoms are sharing 2 electrons with their electron density sandwiched right between the two carbons. And what you can see is that there is no plane of zero electron density between the two carbons. What I mean is that if we look at this electron density, it's one continuous oval between the two. But what happens when we form our second bond? Well, before we just kind of drew this as a line. Took our 2 electrons, we combined them, and this was the extent of our drawing. Now we're going to actually look at what this would look like in space. So we have our initial bond with no nodal planes. But now we need to form an additional bond with 2 electrons. And how do we do that? We already have the space between the two carbons occupied with electrons. And the solution is we're going to draw an orbital above and an orbital below this first bond. And this is going to contain our 2 electrons from the second bond. Now, between these two lobes, there is a region of 0 electron density. And this is due to the fact that we had to make space for the first bond. So if we eliminate a picture of the first bond, what we see is a gap. And this is what we're going to call a pi bond. Whereas our initial bonds, when they consist of just the 2 electrons to begin with, this is what we're going to call our sigma bond. So what are the big differences between sigma and pi bonds? Well, we always form sigma bonds between different atoms. It's the first bond we ever form. So if we look at something like formaldehyde again, carbon, hydrogen, hydrogen, oxygen. This time we're going to go back to drawing the Lewis structure. So we got 6 electrons around oxygen, 4 around carbon, 1 each hydrogen. The first bond we form between carbon and each of the periphery atoms are all sigma bonds. So this is a sigma, this is a sigma, and this is a sigma bond. The electron density is localized between the two central atoms. Now, if we want to combine the unpaired electron on carbon and the unpaired electron on oxygen, we can, which is what we do. But this second bond is going to be called a pi bond. And if we were to look at this spatially, so if we just looked at the carbon and we looked at the oxygen, what we'd see is that our first bond, our sigma bond, all the electron density is between the two. Again, this is our sigma bond. But if we looked at our pi bond is going to have electrons above and below the initial sigma bond. And this is going to be our pi bond. So how do we count sigma bonds and pi bonds? It's actually quite easy. If we have a complicated molecule, something like hydrogen, N2H2. The number of sigma bonds is just the number of bonds between each, or the number of basically links we have between each atom. So we have 1, 2, 3 connections between each of the atoms, so we have 3 sigma bonds. Your number of pi bonds are just the number of additional lines you see beyond the first bond. So in this case, we have 1 pi bond. One way to think about it is the number of sigma bonds is simply equal to the number of total bonds minus the number of pi bonds. So in the case of this molecule, hydrogen, H2N2, we have 1, 2, 3, 4 total bonds, but we have 1 double bond. So we're going to subtract off that double bond, and that'll give us 3 sigma bonds. How about something a bit more complicated? You look at benzene, C, H, In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sigma bonds, and 1, 2, 3 pi bonds. Now, what if we have something more complicated than a double bond? Let's say we have something like acetylene. So if we had acetylene, C2H2, we have 1, 2, 3 sigma bonds, and now we have 1, 2,